Hello everyone, in this video I'll talk about abstraction layer and its implementation in Arduino in a bit more detailed manner. So let us get started. As you can see on the left hand side, I have shown the whole stack of Arduino programming. Right at the bottom there is the chip or the microcontroller, which is in this case Atmega 328P. And then on top of this microprocessor, we have this abstraction layer. Now in this abstraction layer, we get many different things like Arduino core, libraries, functions, and finally, Arduino APIs. Now we shall look at these points one by one. So first term is Arduino core. What it is basically Arduino core. Arduino core is nothing but that part of software which is written just on top of this hardware or the chip. Arduino core is somewhat like board support package, where you really write a lot of code about the low level hardware. This is hardcore software programming based on the hardware details. That is Arduino core, or you can also term it as like board support package. Now you also have these libraries. What are these libraries? These libraries are basically those pieces of code which are used to control some electronic devices or electronic chips. In case of Arduino, there are like many official libraries as well as libraries provided by the community people. These Arduino core libraries, they are written in terms of many different types of functions. And when finally they have written all these details, then it is ready to go and they come up with this Arduino APIs. There are many different types of APIs. APIs stands for Application Programming Interface. These are nothing but kind of functions which are given to the programmer. So programmer actually dwells in this layer. This programmer, they write programs with the help of these API functions. Okay, they just say there are many APIs like digital write, digital read, analog write, analog read, pin mode, all these. They just pass the argument, necessary argument, and sometimes it is just a number or maybe the intended pin number, and that is how just by using these APIs they can control the underneath hardware or the pins of this chip. So as a user or as a application developer, application programmer, what you need to do, you just need to use these APIs. You write programs in this layer, and in the abstraction layer, Arduino people actually hides or they keep all these complex hardware issues secret, and you just deal with the Arduino APIs, that's all. And that is how you write the Arduino code, and it actually makes things much more easier for even an ordinary programmer who does not know about the hardware. Whereas on the right hand side, you can see this is the traditional bare metal programming approach, where you have the chip. So here I have shown Atmega 328P, but it can be any chip. It can be 8051 by any Intel chip or PIC microcontroller chip or any other chip by any other vendor. So here basically you have in between you have one IDE. IDE stands for Integrated Development Environment, which is definitely not the Arduino IDE. Here you use the Arduino IDE, but here you use different IDEs. So there are many different types of IDEs, and in those IDEs you write programs either maybe in assembly language, or maybe in C, maybe in C++, maybe in Python like MicroPython, in Java Micro Edition. So you can write programs in those languages. And also I want to remind you that in this IDE also you get some kind of abstraction layer, but those abstraction layer is really very thin, and you hardly get any major help from that abstraction layer. But here the abstraction layer is really very thick, and here it is very very thin, small abstraction layer. Here it is very thick, very big, and lot of codes are written within this abstraction layer to make things simpler, and here it is not very simple, and what happens is, see, there are many different types of Arduino boards, and these Arduino boards, they use different chips. So here you can see this is Atmega 328P, but it may be some other chip also. But as a programmer, you do not need to worry about what is the chip that is residing underneath. You just write programs here with the help of APIs, that's all. But here it is not so. Here it is 328P, but it may be some other chip, maybe 8051 or any PIC microcontroller. So as this chip changes, you also need to make many changes in this. Whether you write it in assembly or C, you need to look at the data sheet of this chip. You need to look at the technical specifications, mainly two things: technical specifications and the data sheets that you need to take into account to write programs for this chip. So you see, every time you change this chip, you have to write a different program. Okay, so that is how you write programs in bare metal programming approach, and the side by side, this is the Arduino programming approach. Fine. I would suggest you to read these two pages. Now you can see at the first line itself, it has what it has told us, that this abstraction layer, basically it reduces the complexity, and that is how it enhances the efficiency. It brings more efficiency to the table, and also it enhances code portability, at least to some extent. Now, how this abstraction layer is implemented in Arduino? So you see, there are key aspects that I have enlisted here: 4 libraries, functions, board abstraction or Arduino core, and hardware abstraction layer. So I'll start with this board abstraction, which is really at the core. Or when you get the development board or the chip or the microprocessor, the first thing you write is this Arduino core, where you write code for many hardware specific details, and which is sometimes termed as board support package. So every vendor, they provide this board support package along with their development board or prototype board, whatever it is. Okay, now in this Arduino core or board support package, they write, as I told you, many hardware specific details, and that is how they take care of all the complex hardware issues. And also in this then they write these libraries. These libraries are nothing but they are also piece of code which are used to get control over any electronic device or electronic chips. In case of Arduino, there are like official libraries, some official libraries, and also libraries provided by the community people. Okay, so for example, you can see there is a library called where library. There is a library called servo library. Servo library is used to control the servo motors, and where this library is used to control the I2C communication. Now, what is this I2C communication? I2C stands for inter-integrated circuit communication. So what is that? That is nothing but simple two-wire communication between two devices or maybe two chips also. Okay. Now, which chip and all these are basically used in electronic boards or electronic circuits, and there in many situations you need to communicate between two chips, and that is how I2C comes very, very handy. Okay, then these, or finally these Arduino functions or Arduino APIs. Okay, so what are these APIs? These APIs basically some functions which are given to the user to write programs easily. What they do, do with the help of these APIs, they just use these functions and passes some argument, that's all. Sometimes that argument may be any number, or maybe some string, or maybe any particular pin number, and just by that they just control all the hardware that is at the lowest level. So they do not really need to bother about what is there at the lowest level, which chip is there, how the hardware is performing, all these things. They do not need to take care. All they need is to know details about these APIs, how they should be used, and they can write programs easily. Now hardware abstraction layer or HAL, you can see this is also just a way to keep the hardware details secret, or hiding the hardware details, and use just the this type of APIs or these functions to write code. Now here I have shown one piece of code, one program. So right now it may seem to you a bit complicated, so don't worry. In the future videos I'll talk about all this in detail, and you will understand all these things quite easily. Okay, so that's all for today. So we shall meet again in the next video. Thank you.